Welcome back, guys, to the next video of our IPv4 module, which will be on network address translation or NAT. So let us begin. Okay, so before we move in and talk about the NAT, I would like to address one problem that is there. So let's suppose we ask our ISP, which is Internet Service Provider, for an IP address, and let's suppose it provides us a quite like a few range of IP addresses, maybe 5 or 10 IP addresses. But later on, we realize that we want some more IP addresses to be more. We want some more IP addresses as well. So in that case, what happens is that it is a problem for ISP, as it cannot provide us some more IP addresses, as they will be allocated to someone else, and it cannot allow us to get the IP addresses before that particular range, because that might be possible that those IP addresses are also allocated to someone else. So in that case, what happens is that to resolve such kind of problems and to like so that is the one kind of problem, and there is another kind. So let's suppose if I have as I told you, like IP address space is made up of 32 bits only. So at a time, only approximately 2 to the power 32 devices can be connected to the internet. But what if like let's suppose if I keep on assigning each IP address to each particular device, then after some time what will happen that our IP address space will get exhausted, and obviously there are certain restrictions, as we discussed, in like certain addresses, certain special addresses are being used for certain specific purposes. So we cannot use all the IP addresses that are available. So it's a problem. Like if we would have our address space exhausted, and still there will be few devices which would be left out, and no IP addresses would be allocated to those particular devices. So there are two. So we just discussed about those two problems. So in order to resolve those problems, what we do is we create a private network. So what I'm trying to say over here is that, so let's just look at this picture. So in this picture, what we have is that we have just one router, and to this one router we have allocated one public IP address. So the whole internet is going to identify this router on the basis of this IP address. And inside that router, we have assigned a set of public IP addresses, and those IP addresses will be like will not be visible to the internet. So the what if a packet is coming from the internet, it will only look at this particular IP address, with the destination IP address as this particular IP address. It does not know about all of the other IP addresses that are connected inside that private network. So in the private network, we can assign a certain number of devices within that private network, and it will have a certain private IP as well. So in this way, we can have n number of private networks within like there is one private network over here, and same set of IP addresses can be allocated to some other private network, which could be present in some other country or some other world part of the world as well. So this is like the solution to this specific problem that we discussed. So in order to do that, we must have a NAT router. So that is particular screen is known as the NAT, which is network address translation. So what we do is just that it is a mapping between private and universal addresses. So universal or public addresses, so that is this address, and the private address is this one. So when we want to do some mapping between both of them, then that particular scheme is known as network address translation scheme. Okay, so what it does, it says that it allows a set of private addresses for internal communication. Like I told you, for internal communication, we are going to use a set of private network addresses, which will be allocated and which can be increased or decreased. Like the private network IP is 30. It can allocate up to 30 hosts. So we have just assigned only 20 hosts right now. So we can in the future also increase 10 more hosts. So that is the case. Like it is used just for the internal communication. And we also have a set of internal global internet addresses. In our case, we have just one global IP. So it has written like it should have at least one global IP to communicate with the rest of the world, which is like internet. And like to use this technology, we should have a NAT enabled router, and which should have a NAT software as well. So that is the case of network address translation. Now let's look at some more let's look into more detail about it. So there now comes the topic of address translation. So what happens is that, like I told you, like this particular IP, private IP, is like invisible to the internet. So whatever the packet will be coming from the internet, it will just look for the destination IP, which will be the IP of this particular router. It does not know about any of the devices that are present inside that router. So what will happen is that 172, so whenever a host inside our private network wants to communicate with the rest of the internet, so it will have some source IP, and the function of NAT router will be to convert that source IP. Like it will convert that source IP and it will just assign its own IP and remove this particular IP, because the ending part. So that is what the NAT router does. And when a packet would be coming, it will direct that particular packet to the router to which the response should go. So that is the case of address translation. Now moving on, we have three schemes via which we can do the address translation. So in the first one, what we are doing is we are using just one single IP address. So what we have done over here is that we have just assigned to a NAT router, we have assigned just one single IP address, which is 25.8.2. No. Okay, so we have just assigned one single we have just assigned sorry we have just assigned one single IP address to our router. So we have just one single router, and whenever we want to communicate with the rest of the world, we are going to create a translation table which is like that. Okay, and in the translation table, what we are going to store one private IP and the universal address. So let's suppose if so there is a step number one. So let's suppose if this packet is coming and it wants to communicate with the rest of the world, so we'll have the source IP of this particular private network and the destination IP, which would be of someone from the world. So that particular entry will get stored in the table. Okay, like this is a private IP and this is a universal IP to which the packet is going to go. And when the packet will move out of the private network, or when it will move out, the NAT would change its source IP from the private IP to its own designated IP, which is 200.24.5.8. Okay, so this will be the source IP of the outgoing packet after the NAT router. When the response would come, so the response is coming this way. So the source IP, so the destination IP which was over there will become the source IP. Okay, so this is the source IP. Now it will go and look at the translation table which is over there, and it will check like which was the source IP and which private network requested that particular using that particular source IP when it was going as the destination IP. Okay, so now it will check and it will see like the destination IP was this. Now it has reached a NAT router. Now in the NAT router, it is checking for the like source IP, which is like this, and to which particular private IP it corresponds to. So now it will move on, and it will find that it belongs to this particular dot one IP address. So it will route that particular packet to that particular host. Okay, so that is the case of using one IP address. Okay, the disadvantages are like that. So let's suppose if so there are two hosts, and at the same time, both of the hosts want to communicate to this particular IP, which is 25.8.2.10. Then what will happen is that let's suppose I went to the NAT router and I created an entry for one. So this is device number one. This is device number two, and I have created one entry for device number one and corresponding to the IP, which is 25.8.2.10. Okay. Now this device also wants to communicate with the same IP, which is 25.8.2.10. Okay. Now when the response would come, it will just get confused like to which particular device it should route the packet to, because it cannot recognize like is this the response from of the first request, like whichever the request was asked by the device one, or is it the response for the device two, which request was asked by device two. That is the case with this scheme. Now moving on, what we did what we have over the enhancement is that instead of creating just one single IP address, we are going to assign a bunch of IP addresses and global IP addresses to our NAT router. In that case, what will happen? We'll have a few unique IP addresses instead of just one. Okay, so let's suppose in the previous case we have just 5.8, okay, as our IP address for the NAT router. In this case, we'll have four IP addresses. For the previous one, we are just taking like we have assigned four IP addresses. So in this case, what will happen is that the any host within the private network can communicate. So at a time, only 4 hosts can communicate with, at a time, four hosts can communicate to the same external host. So that is the case. Now four internal hosts, four private hosts can communicate with the same external host at the same time. Okay, but it does not allow no more than 4 connections at the same time. So that is the case. So like the number of connections or number of connections at the same time or number of communication channels are restricted. So that is the case with this scenario. So we have got to find a better way of doing the translation. So we reach the third way. In the third way, what we are going to do is that we are going to assign not just the addresses part, but the port addresses as well. Okay, so port addresses and transport layer protocol, which is going to use which we are going to use while asking while requesting or communicating. Okay, so in this case, we have a set of we have one private address and the private port number. Like we have one private host. Okay, so this is private host number one, this is private host number two. And let's suppose I'm communicating. Okay, I want to access google.com and the IP address of google.com is 25.8.3.2. Okay, so I'll store not just the IP address of private network number one, but also its port number. Okay, so this is port number one, and for the device, similarly for the device number two, this is the port number two. Okay, so now when the response would be coming, we will check. When the response would come, this external IP address, which was our destination IP address, it will become the source address as mentioned over here. It will become the source address, the external address, and this private port number which was like source port number at the request, it will become the destination port number at the response side. Okay, and in the so when we do the translation, the combination of both of them will be used for doing the address translation. We'll just check like it should be running. So in order for this particular scheme to work, we should have it should have a unique combination of these two port number. So it should be like that. No two particular devices should run google.com on the same port. So let's suppose if I have device number one and device number two, and if both of them are running google requesting for google.com at port number 1400, then this scenario will fail. Okay, so that's the case I'm trying to say. So the port number should be unique. So that is the case. And there is one more point like which I forgot to mention over here, which is like the number of connections over here is also restricted to one. So like only one device can communicate. So yeah, that's it. Okay, so that will be all from the network address translation module. So thank you so much for watching. In the next video, we'll be learning more about the IPv4 packet forwarding and other network layer protocols as well. So thank you so much.